Hello everyone. This is Team 18 group by 김경진, 승산, 남종훈, 변동현. These are the content. First, we are going to talk about problem description. As a living creature, this question have always become a daily struggle. What should I eat today? This kind of question has been issued for a long time in our life, and it's sometimes we ask ourselves almost every day. In our busy lives, many of us rely on fast food, a convenience meal, or daily apps. But that often means poor nutrition and health trouble. Even when we decide to cook, it's not easy. There are too many recipes online, and most of the time you have to know the exact name just to find what you want. Most recipe apps are based on the text, and recipe apps still want to type the dish name, like kimchi-jjigae. But what if you don't know the name? Maybe you only have a photo, like a tourist who take a picture and ask what it is. How do I cook it? Some apps, when you enter ingredients and a few can spot food in photo, but they usually just show calorie numbers. They don't tell you the recipe. Our system is going to solve this problem. So this is our solution. Our model is AI food guide system that recognizes the type of food from a single image. This model instantly provides detailed recipe based on the information from a single image and make it easily from menu decision process.
And next, we're gonna talk about background and conventional approach. So why don't current solutions solve this? And what technologies let us do better? So as I told you before, there are some limitations of exciting systems. Most recipe platforms are still keyword-based, driven, no name and no result. A few apps recognize food image, but they usually stop at calories logging rather than giving step-by-step cooking guidance. There is no wider use pipeline that goes from a photo to recognition and full recipe recommendation. So our key techs we leverage is computer vision and deep learning. So convolutional neural network extract visual platforms from food image, and also transfer learning. We fine-tune a pre-trained ResNet 50 data on the food uh, 101 dataset, which is labeled from food images, achieving higher accuracy and limited resources. So our differentiator, we fully connect image recognition with recipe retrieval integrated system and connect food image recognition with recipe recommendation.
Next is proposed method. First, let me explain the data collection and preparation process. We use the reliable food 101 dataset, which contains 101 food categories and a total of 100,000 images. It consists of 75,750 training data and 25,250 validation data. In addition, we utilize the dataset of 1,090 recipes from all recipes. The image data was pre-processed by resizing, data augmentation, and normalization, and the recipe data was cleaned of ingredients and cooking steps. Next, machine learning AI approach. We perform transfer learning using a pre-trained ResNet 50 model. We modified the final layer of ResNet 50 to fit the 101 classes of food 101 and trained for 20 epoch using cross-entry loss and Adam optimizer. We set epochs of 20, but reached the peak at the eighth running and then decreased, so we stopped to prevent overfitting. And then we loaded the dataset containing recipe name, ingredient, and the cooking directions. We split the gradient string by commas, split the cooking paragraph into steps using punctuation or numbering. Right one is result. And then finally, we create a dictionary that maps the food 101 name to the recipe name. Right one is result.
Next is the evaluation part. As you can see on the left, we performed batch testing using 20 images from the apple pie class in the food 101 dataset. The model correctly predicted most of them as apple pie with high confidence scores. For example, over 99% in some cases. A few images were misclassified as other dishes like waffles or bread pudding, which shows some noise or visual similarity across classes. On the right, we show the mapping dictionary we built between Food 101 class names and actual recipe titles. This mapping allows us to retrieve full recipes after prediction. As you can see, the dictionary works well for common foods like apple pie or macaroni and cheese. However, if you look below, some Food 101 items such as bibimbap are not mapped to recipes. This is because there is no recipe data.
Let's start test. Here we prepare 4 images. First one is apple pie, and second one is bibimbap. Third one is baby back ribs. Last one also baby back ribs. Let's test. Here you can see the apple pie prediction was successful with 97% confidence. Here is recommended recipe. And the bibimbap prediction was also successful, but bibimbap, we don't have bibimbap recipe, so we cannot get the recipe. Third one, the baby back ribs prediction was failed, and it predicted to lasagna. We don't have lasagna recipe, so we cannot get the recipe. And the last one, the prediction was successful, and here is recommended recipe. In conclusion, this project successfully built an AI system that integrates image-based food recognition with automatic recipe recommendation. The ResNet 50-based transfer learning model achieved strong prediction accuracy, and the mapping to real-world recipe enabled practical user guidance. One limitation we observed is that certain dishes like bibimbap were not included in dataset and therefore could not be mapped. While not addressed in this project, extending coverage to such item would make the system more complete. Thank you for listening.